Now, the hazard function can be actually used to create the survival function. They're related. And we won't jump too much into their relationship, but all that's important to understand here is that there is a formula which allows us to go from the hazard to the survival. And so we can use that formula to get the corresponding survival curve from the hazard curve. And so this is the survival curve that corresponds to this hazard curve. And we see that the survival curve helps us answer the question, what is the probability of survival past any time t easily? For example, if we wanted to know the probability of survival past time 4, then we could read off the graph that it's a little higher than 0.2. At the same time, we can answer questions like, what is the patient's immediate risk of death if they make it to time t, by looking at what the hazard is at 4 and realizing the hazard at time 4 is smaller than the hazard at time 8, let's say. And this relationship is in both directions, so we can actually derive the hazard from the survival curve as well. And once again, we won't worry too much about the actual formula that gives us their relationship, but you can interpret this formula as the hazard is the rate of death if age t. And so using the survival curve, we can generate the corresponding hazard curve. And here we can see that the hazard for this patient population is a constant function. And what that means is that the immediate risk of death given survival to any time t is constant. Here it is 1. And here's the corresponding survival curve for that. So we've now looked at survival and hazard as two functions where one can be used to derive the other and vice versa.